5.3 is on adding and subtracting rational expressions. And this joke will make sense if you knew that this fraction is called a complex fraction. So it was just too complex for that student to solve, or actually to simplify. We're going to be working with, well, we will be factoring again, so there's complex fraction like I just mentioned. We're going to be simplifying, or adding and subtracting, and we're starting with this first example, and this one's very nice because the denominators are the same. So just like when you're adding fractions, we have to have common denominators. So since these denominators are common, then the denominator of the sum will be the same, x plus 3. And then we simply add the numerators. So you're going to have 3x plus, whoops, don't do that. 3x plus 2x is 5x. Negative 4 plus 5 is 1. It does ask us to identify any x values where it's undefined. So for that, again, we're going to look in the denominator, and x cannot equal negative 3, because then the denominator would be 0. This next one, again, we have same denominators, so we'll keep those the same. Now this time we are subtracting, and you have to proceed with caution when you're subtracting. Because you're subtracting this entire fraction, or this entire numerator, you need to distribute the negative to both of these. So one way you can do that is you can change the negative to a plus, but then you have to distribute the negative to every term in the numerator. When you distribute that negative, the negative becomes a plus right here in the middle. So now I have 2x minus 4x, and negative 1 plus negative 4 is negative 5. Identify any x values where it's undefined. Well, you could think about this. In order for the denominator to be a big fat 0, this x squared has to be negative 2. Is there any number you can square and get a negative? The answer is no, because x squared is always positive. So this one's defined everywhere. Defined everywhere. Or you could just not even bother writing it. Another way you can look at that, if that doesn't make sense, is you can make x squared plus 2 equal to 0 and try to solve it. So we would subtract 2 from both sides. Then we would take the square root, the plus or minus, and the square root of a negative involves I. So you're not going to get a real answer on that one. So it's defined for all reals. Now do these on your own, and then I will write the answers for you once I find them. Okay. So to save time, I'm just going to write the answers. If there's any of these that you want, that you can't get the right answer, then we can talk about it during class. You can just make sure and ask me. Oh, I can't even write correctly, that's wrong. X cannot equal plus or minus root 3. And on this one, hopefully you distributed the negative and changed that to plus and minus. That's going to change that sign, that's going to change that sign. And then when you add all this stuff up, you should have gotten x squared plus 3x minus 3 all over 3x minus 1, and x cannot equal 1/3. Next type of problem. We are now going to find the least common multiple. So on the previous examples, the denominators were the same. We didn't have to worry about finding the least common denominator. But from here on out, we're going to have denominators where we need to get the least common denominator. The least common multiple is the same as the least common denominator. When you have factors like these, you in your least common multiple has to include every factor. So 2 needs to be included in there, 3 needs to be included. So you're going to have 2 times 3. You need to look at the x's, and what you're going to do is you're going to choose the x with the highest power. So that's going to be x to the 5th. So choose the variable with the highest power. And then the y's, you've got y to the 4th and y to the 3rd, so we need to choose y to the 4th because it has the highest power. So the least common multiple is 6x to the 5th, y to the 4th. The 6 is the smallest number that both 2 and 3 will divide into. if you had, say you had 2 and 6, say those were your two numbers and you were trying to find the least common denominator, 6 would be the least common denominator because 2 will go into 6 and 6 will also go into itself. So 6 is the smallest number that they'll both divide into. And you've done this, throughout your careers when you're finding least common denominators when you're adding and subtracting fractions. On example B, we have a polynomial. So what we have to do first is we actually have to factor that. Now fortunately these are both going to be fairly straightforward to factor because there's a 1 in front here. So we know that those are x's, and two numbers that multiply to -4 and add to 3 are going to be +4 and -1. Then over here I'll put an and symbol. Same deal, we're going to have two sets of parentheses with x's, and that's going to be -2 and -1. So now to get the least common multiple, every factor has to be represented in the least common multiple. We need to include every factor. So x plus 4 needs to be in there. X minus 1 needs to be in there. X minus 2 needs to be in there. X minus 1 is already in there, so we don't need to put it in twice. You don't want to. You want it to be the smallest. Now, let's say you had something like, this is a little mini example. Say you had x plus 3 squared and x minus 1, that was on one of them, and the other one was x plus 3 and let's say, we'll just say that. That's good enough. So if you were finding the least common multiple of these, you would choose, just like you did over here where you had y to the 4th and y to the 3rd, you chose the one with the higher power. You're going to do that here as well. You've got x plus 3 squared and you've got x plus 3 to the 1. So you're going to choose the one with the highest power. And then we also need x minus 1 because every factor needs to be included. And then this x plus 3 has already been dealt with. We've already, considered it when we considered this one. So that's how you would do the least common multiple on something like that. And you can just leave these. I'm not concerned about you multiplying them out, so just leave them. Okay, so do these on your own, and then I will just give the answers. The answer to this one is 12x to the 5th, y to the 7th. This one, you have to factor each one of these. Hopefully you factored that one like so. And you end up getting, here I'll do this one too real quick. I knew I wasn't going to do them, but I can hardly resist sometimes. So when you get your least common multiple, it would be x plus 2 times x minus 2, and you also need the x plus 3 in there. So make sure you represent every single factor. And if the factor has powers on it, you're going to pick the one with the highest power. Now we can utilize all this stuff we've learned so far and put it all together into a problem like this. When you're adding these, you need to factor the denominators. So if you like steps, the first step is to factor the denominators. The numerator is going to stay the same. Just bring it along. And this one's going to be nice and easy for us. They're giving us some nice, easy ones to work with. Plus, and then we've got x plus 1 over there. Second step is to find the LCD or the LCM, least common denominator. And that's going to be, in this case, well, I don't really want to write it there. Well, whatever. Anyway, it's going to be x plus 2, because we need that one. We need the x plus 1. And then we've already got the x plus 1, so we don't want it again. So this is our least common denominator right here. And then the third thing we need to do is multiply so that both fractions have the same LCD. Well, fortunately, the one on the left already has the LCD, so we are going to leave it alone. Now, this one on the right needs to have an x plus 2 in its least common in its denominator. But you can't multiply the bottom without also multiplying the top. So that's a legal move now, because really all I've done is multiplied this whole thing by 1, because x plus 2 over x plus 2 is just 1. So I have not changed the meaning of the problem. Fourth step is you might have to distribute here, which I'm going to need to do. Distribute if needed, and then add the numerators. So I'll come down here. I'm just going to bring this one along, x minus 1 plus, and then this one's going to be x squared plus 2x. All over, we can put them all over the same denominator now. Add numerators, put all over same denominator. And then finally simplify the numerator. So I've got x squared, 2x plus x is 3x, and minus 1 all over, and then the denominator. You can either leave the denominator the way it is, or you can distribute it. I'm not picky either way. A lot of times it's actually easier to leave this the way it is. I was going to look at the book real quick and see what they did. Oh, they said or, just like me. So either one of these, this is acceptable, or if you want to distribute this back out, you can. But for time's sake, let's just leave it the way it is. Now, I almost forgot, we have to look. It says identify any x values for which the expression is undefined. So really, before I box this in, I should have had a comma and said x cannot equal. We're going to look in the denominators. We cannot have a -2 or a -1. That should be included with your answer. Not too bad. Kind of fun, I hope. I hope you like it. This one, we will do it together. So first step is least common denominator. Actually, the first step should be to factor the denominators. Is that what I said? I'm just curious. That's exactly what I said. Factor the denominators. First denominator is already factored. Second denominator, that's a difference of squares. That's x plus 3 times x minus 3. Okay, that was the first step. Second step is to find the least common denominator. I need an x plus 3. This is my least common denominator. It needs an x plus 3. There's already an x plus 3. We need an x minus 3 also. So that's step 2, least common denominator. Step 3 is to multiply so that both fractions have the same LCD. This one's already good. We don't have to mess around with that one. Over here, this one needs an x minus 3. So I'm going to multiply that to top and bottom. Please show this work right here. Some people try to skip it, and I really want to see all your steps. Next step is to distribute the top. So I'm going to have x squared minus 3x. And I can put this all, remember this was all kind of one step, and we're going to write it all in the numerator. I'm just going to bring this all along. I've got plus a -18, which is the same as minus 18. And we're going to put it all over the same denominator. And this one, you cannot combine the numerators, so it's good. Now, sometimes you can check. Can you factor that? 9 and 2. Oh, 6 and 3. This looks like it's going to simplify. 2 sets of parentheses, xx minus 6 plus 3 all over x plus 3 times x minus 3. Well, how about that? So we have an additional step on this problem. We could simplify the numerator by factoring, and then these will cancel. We get x minus 6 over x minus 3. And this time I'm remembering we need to say x cannot equal. And we have to be careful here, because remember, you from the previous lesson that when you're figuring out where it's undefined, you have to consider the ones before you canceled. So -3 and +3 are both need to be included because this expression came from this one. And that is example 3b. Very interesting, isn't it? This one you can do on your own. I'm just going to give you the answer. Ooh, this one's a little different. Shoot. We need to do this one. I need to show you this one because it's a little different. The reason it's different is because you're going to have some numbers. So when you factor you start by factoring the denominator. You're going to pull a 2 out of there. Keep the numerator. I'm going to pull a 3 out of this one. And then when you find your least common denominator, you have to do each factor. You need a 2, you also need the 3, and then the x minus 1. So 6 times x minus 1 is what you should be getting for your denominator. And then you could proceed from there, and I think I'll at this point just give you the answer. So the answer is 15x minus 4 all over 6 times the quantity x minus 1. See, that's that common denominator that's right here. And then x cannot equal 1. If you want to go over any of these in class, I'll be glad to help work through these with you. 3b. So this one again is a one for you to do on your own. I'm just going to give you the final answer. The final answer is x plus 2 over x plus 3. X cannot equal -3. I don't know why it says example 1 because it really is not. It should be example 4. This time we're going to subtract. Subtraction and addition follow the same process. The only difference is there's a negative that's going to eventually have to get distributed. So the same steps apply. Factor the denominator, so I'll carry the numerator along. This is good difference of squares, x plus 2 times x minus 2 minus my numerator, x plus 4 over x plus 2 is already simplified. Well, this is going to be a fairly easy LCD. Now at this point, you might be getting to a point where you can see the least common denominator and you don't need to write it down. I'll write it down again just so you see, but we need an x plus 2 in there, we need an x minus 2, and we've already got the x plus 2. So now we're going to multiply the one on the right by, it needs an x, let's put this in parentheses, put that in parentheses as well. We need an x minus 2 on this one. Top and bottom. Please show this work. Now, bring down the numerator. Okay, so right here, for those of you that don't mind using up a lot of paper, you can, actually I'm trying to think about the best way to do this so you'll make least likely to make mistakes. Well, I'm going to show you 2 ways you can think about this. So if you don't mind using a lot of paper, you can bring along this minus, so this minus is coming down. You need to put a big parenthesis, and then you're going to FOIL this out. So we've got x squared minus 2x plus 4x minus 8. That all has to be in parentheses because you're subtracting that entire thing. That is super important. All over the denominator, x plus 2 times x minus 2. Then this is going to be, what I'm going to do is do a little work up here. So I don't have to write everything down again. I'm going to say x squared. This is 2x minus 8. Now on this next line, I'll break down the 2x squared minus 16. This negative, I'm going to distribute it. So it's going to change to a plus, and then I'm going to change the sign on everything inside the parenthesis. So that becomes negative x squared minus 2x plus 8, all over the denominator. Subtraction can be tricky. You have to be careful. I can't emphasize that enough. I'm trying hard here. this minus has to get distributed to this entire product. So that's why I've got the entire product in parentheses. When you do distribute it, this changes to a plus and the sign on every term changes. Now, there is another way you can write it to get down to this point, especially if you don't like using a lot of paper. You could distribute this part up above. I'll do it in a different color. So that's x squared minus 2x plus 4x is the same as plus 2x and then minus 8. Then what you can do is you can do this step here, right here. You could change this to a plus and then change the sign on every term. And then take this green part down to here. So it just saves a little bit of writing and a little bit of paper. Of course, when you get really good at these, you can do them in your head, but I still caution you with that because you have to be careful with that negative. You can easily make mistakes. So now I'm down to here, regardless of which way I go about doing this. And I've got to combine my like terms, so I've got x squared, we've got a negative 2x, and we've got a negative 8 all over the denominator, x plus 2 times x minus 2. Can we factor the numerator? I kind of think we might be able to do that with a 4 and a 2, a negative 4 and a positive 2. You do need to keep simplifying if you can, so it's important to check. And my x, where am I at? My x plus 2's are going to cancel, so I'm left with x minus 4 over x minus 2. X cannot equal, and we have to go back up to our original one before we cancel. Then we've got negative 2 and positive 2 there. You don't want to base it on the final result because this came from this. Here's the final answer. Proceed with caution when you're subtracting, please. I don't want to see you making those mistakes with those negatives, just for your own sake, if nothing else. Try this one on your own. I'm looking to see, okay, where I'm at here. So this one ends up becoming, the answer is x plus 4 over x minus 8. X cannot equal plus or minus 8. So you could see that before this, we had some factors that canceled out. Hey, we're to the complex fraction. How about that? These are complex, obviously, because you have a fraction over a fraction, so they're kind of complicated. And on this one, we're going to assume all expressions are defined, so we don't have to do that last step at the end. Now, there are two methods, so I will show you each one. I'll show you both, and then you get to choose which one you prefer. The first method is to get a common denominator in the numerator and combine those fractions. So maybe I better write the steps down. Number 1, add the fractions in the numerator. So I'll do the work over here. That means I have to get a least common denominator, which is going to be 4 times x. And I'll just do some work up here. So this one needs a 4 and a 4. This one needs an x and an x. So I'm going to have 4 times 2. These are times. So I'm going to have 8 plus x times x is x squared all over the denominator, x plus 1 over x. Second step is to flip the denominator and multiply. Multiply to top and bottom. So what that looks like is, we'll go to this color, flip the bottom, so that's going to be x over x plus 1, in other words, the reciprocal. And I have to do that to the bottom and the top. You have to do it to both, because what I'm doing now is this is 1. Something divided by itself is a big fat 1. So I'm only multiplying this thing by 1. I'm not changing the meaning. The reason you can do that, as I'll just show you again, if you had 8 plus x squared divided by 4x, and all of that's being divided by this fraction, you could write it horizontally like that. I just rewrote this vertical format into a horizontal format, and then we know from our work with fractions that when you're dividing fractions, you flip the second one and you multiply. So notice how this is the same as this numerator here, which makes sense because the third step over here is, guess what happens to the denominators? What's x plus 1 divided by x plus 1? Well, that cancels, doesn't it? X divided by x, that cancels. You end up with just getting a 1 on the bottom. So cancel out the bottom fraction. And now you just have the top fractions divided by 1, which means it's just the top fractions. So then you can go ahead, and the fourth step is to simplify. Multiply the numerators. Multiply the tops. And let's see, to do that, this brings us back to lesson in section 2. These x's will cancel. Oh, let's go to a different color. I'll undo that. Let's go to green. Those cancel out. 8 plus x squared doesn't factor. That's a sum of nothing. So on the top, you're going to have 8 plus x squared times 1. And on the bottom, you're going to have 4 times x plus 1. So we can write that like so. Can you cancel the 8 and the 4? No, you cannot. And the reason is there's a plus right here. 8 and x squared are terms, and we cannot cancel terms. We cannot cancel things that are added and added and subtracted. You can only cancel if it was 8x squared over 4 times x plus 1. If you had something like this, then you could cancel. 4 goes into 8 twice, and you would get 2x squared over x plus 1. Up here, these are terms that are being added. Down here, these are factors. Sorry, they are being multiplied. You are allowed to cancel factors. We can cancel factors. Super important. If you can remember those two things, you're going to be doing good. Now, what I'm going to do is I'm going to erase this whole board. Oh, so here was our answer. It's defined everywhere, we're going to assume, so we're not going to worry about that part. I'm going to erase this whole board, and I'm going to show you a second method for doing the same problem. So we'll clear the annotations, start back over again. This time, it's method 2. Find, number 1, find the LCD of every denominator. So up here we have 2 fractions, and down here we have 1 big fraction. So you look at x, 4, and x. And the least common denominator is going to be 4x. So in our case, it's 4x. So number 1 is 4x. Second step, multiply every fraction by the LCD that you found. So let's do that. So let me start with my original, 2 over x plus x over 4 all over x plus 1 over x. So we'll go to a new color, choose orange. Every single one of these fractions is going to get multiplied by 4x. To do that, you put the 4x up in the numerator of its own little fraction. So 4x over 1. I'm going to put parentheses around that. Okay? Every single fraction, like these fractions are separated by a plus sign. If there was a minus sign, you'd still do it to each one. Now, multiply and simplify. I'll just put simplify here. So up here, let's go to a new color. These x's are going to cancel, and you're going to have 4 times 2 is 8. Here, these 4's are going to cancel. I'm going to have x times x is x squared. Down here, these x's can cancel because x is being multiplied. It's a factor. And I'm going to have 4 times x plus 1. Well, how about that? We're done already. That was easier, wasn't it? Easier, A? You know what's funny is I tend to do it the other way. That's just how I go to and do it, and this is actually faster. I always seem to do things the long way. But you are welcome to do it this faster way. And I'll try to do it the faster way more often myself. So these are intended to be on your owns, although I kind of wonder about these. You know what? I think I'll go ahead and do them. Try them on your own, and then I'll do them for you too. So we need to factor the denominator on this one. Okay, well this one, you only have one fraction over another fraction. So there's method 1 and method 2, there's really, they're practically the same. So method 1 would be to go ahead and multiply top and bottom. We don't have to add the numerator because it's already simplified into one fraction. Because the reason I know that is because this entire denominator is one big chunk. It's being multiplied together, so there's not two separate fractions. I'm just going to multiply top and bottom by the reciprocal of the denominator. So this is method 1. Those are going to all cancel out to 1. And now we can work with our numerators, and these are going to cancel, and we're just left with x plus 1 over, oh, gee, look, that's silly me, those cancel too. Now when those cancel, notice your x is on bottom. That means these cancel out to a 1. So this is actually, it's just going to be 1 over x. Okay, let's do it with method 2. Actually, method 2 on this one might even take a little more work because you have to find the least common denominator. And that means I should have written this factored form. Here, let me get rid of this other one because I don't want to confuse you. All I'm doing is rewriting this in factored form. Now, the least common denominator is going to be x plus 1 times x minus 1 because this x minus 1 is already included in that. So this method number 2 is to multiply both fractions by the least common denominator. Let's put it over 1. So in this case, I'm just multiplying top and bottom by the least common denominator. And then that's going to cancel, that's going to cancel, that's going to cancel. And you're going to get x plus 1 on top over 1, which is the same as x plus 1, all over, and then on bottom you're going to have x times x plus 1. And now these will cancel again. You'll have a 1 on top, so you'll end up with 1 over x. On this particular problem, I think method 1 actually is a little easier. Okay, I'm clearing the board. Now we'll look at the second one. This one, I'll go ahead and do as well. This one again, you have two fractions. There's just one on top and one on bottom, so you don't have to combine anything to begin with. Now what I am going to do is I'm going to factor that 3 out of the bottom. Okay, I'm just going to flip the bottom and multiply to top and bottom. I think that's just the easiest way to do these particular ones. Oh, look at this. 3 goes into 6. Why? Let's simplify that first. Oh, weird. Isn't that there? Okay, there we go. Might as well make it as simple as we can. So now I'm going to flip and multiply top and bottom. Those are all gone to 1. They're out of there. Now, oh, look at this. That cancels. 2 goes into 20 10 times. That was cinchy. Cinch. Funsies. And guess what? We are on our last example, I do believe. These problems are rather interesting. They're somewhat tricky. You have to think about them a certain way, otherwise they're really confusing. We've got a freight train averaging 30 miles per hour traveling to its destination with full cars and 40 miles per hour on the return trip with empty cars. What is the train's average speed? And it's not as simple as adding 30 plus 40 and dividing by 2. Sad to say. And why isn't it that simple? Not sure. I'll have to think about that and get back to you. So this is the correct way to do this. Well, for one thing, we're dealing with rate, distance, and time, so we need to remember dirt. D equals R times T. And the overall question is asking, what is the train's average speed? So overall, we want to know the average speed. Speed, we're going to use dirt to figure out what speed is. Speed is the rate. So if you divide both sides by t, you'll get rate equals distance over time. So the average speed is the total distance divided by the total time that the cars are moving. So that's the first step. Second step, figure out what the total distance is, how to represent it. Well, the train is going, starting somewhere, it's going to its destination, and it's going to turn right back around and go back to where it started. So how do the two distances compare? They are the same. So let's call the first distance there d, and on the return it's going the same distance, d again. So how far has it gone total? 2d. It has gone a total distance of 2d. Now, to get the time, well, we have to use dirt again, individually. We know that, let's just say on the first leg, we'll use this formula, d. We know the distance that it travels on the first leg is d. R, the rate on the first leg, we actually know that. It's averaging 30 miles per hour on to its destination, so that's the first leg. So it's going 30 miles per hour. Now the other thing too is, we're not going to worry about the units because it'll be in miles per hour, so distance will be in miles, time will be in hours. Oh, sorry, I'm already dividing. I got a little sidetracked there. Got a little ahead of myself. Okay, so d equals r, and then t we don't know. Time. I had to look at something for a sec. Okay. I'll call this time 1 for, this is trip 1, leg 1. This will be leg 2. Because is the train going to have different times on each leg? Is it going to take it longer to do one of the legs than the other? Yes, because it's going only 30 miles per hour on the way there, but it's going faster on the way back. So the times will be different. Now, down here, I need total time. Well, total time is the time of leg 1 plus the time of leg 2. So t1 plus t2. Over here, I'm trying to figure out what time 1 is. I've got this little miniature formula. I divide both sides by 30, and I get d over 30. So time 1 is d over 30. If I do the same thing for the second leg, I will have the same distance. The distances are the same. The rate on the second leg is 40 miles per hour, and that's going to be time 2. So if you divide both sides, you're going to get d over 40 is time 2. So that means this formula becomes 2d over time 1, which is d over 30, plus time 2, which is d over 40. All that work just to get to this formula. And then we get to simplify the formula. I'm going to erase all this stuff so that we can work with simplifying this now. You do need to use this setup, though, on these problems. You can't just simply average the 30 and the 40. As you'll see, we'll get a different answer than if we were to just average them. I'll have to think about why that is, but right now I don't want to waste your time trying to figure that out, like why it isn't just so simple. So let me bring my formula over here. This we are going to simplify. Now this time, we have a sum of fractions on the bottom and one fraction, so to speak, on top. In fact, what I'm going to do is make this into a complex fraction. This is like my major division bar, and I want a fraction on top over a fractions on bottom. So I'm going to write my 2d over 1 so that I have a fraction on top, and then I've got these sum of fractions on bottom. Now it's in complex fraction form. And you do want to do that. You want a fraction over a fraction. Okay. I think method 2 is going to be faster on this one. So let's do method 2. Method 2 is to find the LCD So 30 and 40, what's the smallest number that 30 and 40 both divide into? And you could think 3 and 4 is 12. So in this case, it's going to be 120. So what we're going to do on this one is we're going to multiply every single fraction by, so the LCD was 120. We're going to multiply each of these by 120 over 1. This one has to be multiplied by 120 over 1. And this one has to be multiplied by 120 over 1. You have to multiply every single term. If you don't, you're going to get it wrong. Now on this top one, we're going to have 2 times 120, which is 240d. I'm going to still put it over 1. And then down here, 120 divided by 30 is 4d, because there's a d there, plus, and then 40 goes into, so here we'll cancel these so you can see what I'm doing. 40 goes into 120 3 times, so I've got 3d. And you know what, to be honest, I really don't need that one up there. So let's drop it now. I didn't need to put that in there. Oh, check this out. We can keep simplifying because there's d's in each one of these. Or, you know, another way to think about this, maybe it make more sense. 240d over 4d plus 3d is 7d. Let's do it that way. Then you can see the d's are going to cancel, and we end up with 240 over 7. And when you divide that, you will get, what I got here on my notes, 34.286. And it is, what are we finding here? We are finding, well, I erased it, but it was the average speed. So speed is in miles per hour in this case. Kind of fun. I get to see all these different methods. This is the lesson quiz, so I'll probably make this be the warm-up. Okay. Be sure to ask questions in class if you want.